Welcome you all in the lecture number 14 of Engineering Mathematics 1 MTL 1025. In this lecture we will going to discuss the Taylor series expansion for function of two variable, right, about any arbitrary point. In previous class we have discussed about Taylor series expansion of function of two variable about origin, right. See, what is Taylor series expansion of function of two variable? This is the example. This is one example. Taylor series expansion of function of two variable. We already discussed in previous class. What is that? About any arbitrary point, we satisfy this condition that a is less than x is less than a plus h, and b is less than or equal to y is less than b plus k. Right? If x and y lies between this rectangle, that is a plus h, right? If x and y lies in this rectangle, then Taylor series expansion and also other conditions also satisfy, that is f is finite, all its partial derivative are finite of up to nth order, and f is continuous, all its partial derivative are continuous, right, in this rectangle. Then the Taylor series expansion f of a plus h b plus k is equal to f of ab h dou by dou x of f k dou f by dou y 1 by factorial 2 h square dou 2 dou x2 of f plus 2hk dou 2 dou x dou y of f plus k2 dou 2 dou y2 of f, right, and so on. In this way we have to expand this function. What is the function? Function is sin xy, right? This function we have to expand about 1 and pi by 2. Why? This says that you have to expand the function sin xy, not about the 0 0, right? This is not 0 0 point. This point is 1 and pi by 2. How we know that this point is 1 and pi by 2? Let us see in this way, right? What is a plus h? Let us assume that a plus h is x. What is fxy? Fxy is sin xy, right? It is function of two variable. If we consider this fxy by this, then a plus h, what is a plus h? That is x. What is b plus k? This is y. Okay. A plus h is equal to x. Then what is h? H is equal to x minus a, right? And what it gives that a is equal to 1, that is x minus 1. Next, b minus k is equal to y. It means k is equal to y minus b. Then what is k? Y minus what is b? B is pi by 2. How you know this? This is k and this one is h, right? We have to expand in this power. It means our point is 1 and pi by 2. We have to expand our function around this point, and or in other way we can say that about in the power of x minus 1 and y minus pi by 2, right? See how we expand. Procedure is same, but instead of origin 0 0, we have to evaluate value of the function and value of all its derivative at the point this. Okay, when everything is same as the previous example. See, let fxy is equal to sin xy, right? Then what is h? H is equal to x minus 1. What is k? K is equal to y minus pi by 2. Okay. What is ab? Ab is equal to 1 pi by 2. Right? See, what is the value of the function at 1 and pi by 2? Sin xy. This is equal to sine of 1 into pi by 2. What is sin pi by 2? That is 1. Now, differentiate this sin xy with respect to x. It means dou f by dou x. What is dou f by dou x? Y into cos y. Sin derivative of sin xy is cos xy, and derivative of xy with respect to x is y. Now put x is equal to 1 and y equal to pi by 2. Then this is equal to pi by 2 and cos pi by 2. What is cos pi by 2? 0. Then pi by 2 0 equal to 0. Okay. Then derivative f of y xy. What is this? X into cos xy. Right. Partial derivative of f with respect to y. It means dou f by dou y. This is dou f by dou y. Dou f by dou x. Okay. And this is x into cos of xy. Similarly, what is x? X is equal to 1 into cos 1 into pi by 2. That is cos pi by 2. Cos pi by 2 is 0. That's why this is 0. Right. Now evaluate second derivative. Second derivative is this. What is y square? Y is equal to pi by 2. Then y square is equal to pi square by 4. And this is sin pi by 2. This one is pi square by 4. Similarly, dou 2f, this is dou 2f by dou x2, and this one is dou 2f by dou x dou y. Okay, this thing is this. Now put all the values. This is cos pi by 2, this is 0, x is 1, y, right? Then this is minus 1 into pi by 2 into sin pi by 2, that is minus pi by 2, right? Similarly, dou 2f upon dou y2, this is equal to minus 1, right? Put all these values of function and its all second order up to second order partial derivative in the equation number star, right? Then this becomes f of xy is equal to f of 1 pi by 2, and what is h? H is x minus 1. In the formula it is h is x minus 1. F of x, right, means dou f dou x, fx 1 pi by 2. This b already evaluated, this is 0, this is 0, this thing we already evaluated, this is 1. Okay, 1 by factorial to h square means x minus 1 square, dou 2f by dou x2 1 pi by 2, right? 2 h and k, 2, what is h? X minus 1. What is k? Y minus pi by 2, dou 2f dou x dou y in this one, right? Y minus pi by 2 square dou 2f dou, right, at 1 and pi by 2. See, what is the first term? This term is 1. Okay, this is 1. X minus 1, what is this term? This term is 0. So this is 0. This term is 0, right? This is 0. Now 1 by factorial to x minus 1 square, what is this term? This term is minus pi square by 4 in the previous table. This is 2x minus 1, y minus pi by 2. What is fxy 1 pi by 2? This is minus pi by 2. In the table it is given. Then y minus pi by 2 square, f of y 1 at pi by 2. This is minus 1, right? Then after simplification of this term, we got this series. Okay, this is the expansion of function of two variable, that is sin xy about the point 1 at 1 and pi by 2. Okay, about this point, right? This is Taylor series expansion of the function of two variable which satisfy the condition that fx, fy, fxx, fyy, fxy, dot so on. These all are finite and continuous in closed interval AB, right? This thing, sorry, finite and continuous in the rectangle AB, this rectangle AB, A plus H, B, A plus H and B, A plus H, B plus K, and A, B plus K. Okay, now see the second example. Expand e to the power x cos y at the point 1 pi. This is I think pi by 4. Please correct it. This is pi by 4. Expand e to the power x cos y about the point 1 pi by 4 by Taylor series expansion. This is the formula of Taylor series expansion. Okay. F of x plus h or a plus h y plus k is equal to this one, right? Then again evaluate the value of the function at the point 1 pi by 4 and all its derivative at the point 1 and pi by 4. See, fxy is equal to e to the power x cos y. What is ex? X is equal to 1. Then this is e to the power 1 e cos pi by 4. Cos pi by 4 is 1 by root 2. That is e by root 2. Okay. E to the power x cos y. Then e to the power x is 1. What is cos y? Cos pi by 4. This is e by root 2. Okay. Now dou f by dou y. Differentiate this function. That is fxy is equal to e to the power x cos y. Now what is dou f by dou y? Dou f by dou y is equal to e to the power x. Derivative of cos y is minus sin y. Okay. Then this is e to the power minus e to the power 1 sin pi by 4. That is minus e by root 2. Similarly, dou 2f by dou x 2, dou 2f by dou y 2, dou 2f by dou x dou y. From the table, this table, putting all these values in this equation, right? Then we got Taylor series expansion of the function e to the power x cos y at the point 1 pi by 4. Either you can say at the point this, or you can say that in the power of x minus 1 and y minus pi by 4. Both are same. Either you expand this function, in the power of f of xy e to the power x cos y, expand this function in power of x minus 1 and y minus pi by 4. Okay. Or expand this function about the point 1 and pi by 4. Okay. Both are same statement. Now putting all the values from here, these values in this formula, right? And what is h? H is x minus 1. What is k? Y minus pi by 4. Okay. We obtain h is x minus 1, k is y minus pi by 4, right? We got this function at 1 and pi by 4, this x minus 1 dou f by dou x at 1 and pi by 4 e to the e by root 2. Then k function at 1 and pi by 4, this thing 1 by factorial 2 x minus 1 square e by root 2, 2x minus 1 y minus pi by 4 minus e by root 2, y minus pi by 4 square minus e by root 2, right? That's one. Now simplifying this, you got this series. Okay. Now let us see another example. This example is somehow different from the above two example, that we have to compute the value of the function this. It means what is our function? Our function is given that f of xy is equal to tan inverse xy. Now we have to compute what is 0.9 minus 1.2. This is equal to tan inverse 0.9 into minus 1.2. Okay, we have to compute this. Now how we compute this? We know that what is 0.9? 0.9 can be written as 1 minus 0.1. Okay, this is equal to 0.9, right? What is minus 1.2? This is minus 1 minus 0.2. Okay, minus 1 minus 0.2. This way we can write this. Okay, If we consider h is this, we consider h this and k 0.2, and we apply Taylor series expansion, right? We consider h is 0.1, k is 0.2, and we apply Taylor series expansion. Then what is the point? What is our point? Our point is a plus h, sorry, a plus h, b plus k. What is a? 1 minus 0.1, and b is minus 1 minus 0.2, right? It means our ab is 1 minus 1. Okay, our AB is 1 and minus 1. See here, AB in the formula it is mentioned that x and y. This x is 1 and y is 1, or A is 1 and B is minus 1. Okay, now we have to evaluate. We have to evaluate the function and all its derivative, right, at the point 1 and minus 1, and putting the function value and its derivative value in the equation number 1, right? Then we find what is the value of the function at the point 0.9 and minus 1.2 using Taylor series expansion, right? Let us see. Now one thing is clear, that what is our point AB, we call it AB or XY, whatever you want to say. This is same thing, XY, as mentioned in the table. Our HK 0.1, sorry, minus 0.1 and minus 0.2, right? This is HK. Let us see. What is fxy? Fxy is tan inverse xy. Okay. See, x equal to 1, y equal to minus 1. Then x equal to 1, y equal to minus 1. F of xy, tan inverse xy, tan inverse 1 and minus 1. This is tan inverse minus 1. What is tan inverse minus 1? Minus pi by 4. Okay. Now differentiate this f with respect to x. Dou f by dou x. What is dou f by dou x? Dou f by dou x is equal to 1 upon 1 plus x square y square, and derivative of xy with respect to x, that is y. Okay. Now evaluate value of this at the point 1 and minus 1. What is that? 1 into minus 1, 1 plus 1 square minus 1 square, that is minus 1 by 2. Okay. Similarly, what is dou f by dou y? Dou f by dou y is this. Okay. Now see, ex. What is ex? X is 1. What is 1 plus 1 square into minus 1 square? What is this? This is 1 by 2. Okay. Now dou 2f by dou x2. Again differentiating dou f by dou x means this thing, this one, with respect to x. We got this term. And evaluating this term at the point 1 and minus 1, right? We got 1 and 1 by 2. Similarly, dou 2f by dou y dou x, or dou 2f dou x dou y. First you have to differentiate this. We have to differentiate dou 2f dou y dou x, means this thing. Differentiate this with respect to y. Dou 2f dou y dou x, that is dou by dou y of dou f by dou x. This is dou by dou y of y by 1 plus x square y square, that is 1 plus x square y square into derivative of y, that is 1, minus y into derivative of denominator into 2xy divided by 2xy square divided by 1 plus x square y square whole square, right? And simplify this, you got this term, right? Now putting x is equal to 1 and y equal to minus 1, right? This term is 1, 1 minus 1 is 0, right? And denominator is positive, this is 0. Similarly, dou 2f by dou y2, dou 2f by dou y2 is 1 by 2. Now putting all these values of function and its derivative value in this formula, equation number 1, right? We got this thing, right? After simplifying this, pi by 4, you can evaluate pi by 4. After simplifying this, if simplifying this, we got this. It means the value of tan inverse 0.9 into minus 1.2 is equal to minus 0.8235. Okay. Okay, we will stop here. In next lecture we will discuss some more examples. Okay, thank you.